If you're looking for a content explaining what is Tetragon and how to configure it, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the security playlist where we covered a couple of episodes. We recently explained what is Falco. In this episode, we presented the various features of Falco and moreover, the value of runtime agents such as Falco. But today's episode is going to be focused on another runtime agents also relying on eBPF, and I'm referring to Tetragon. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what we are going to learn from this episode. We'll start directly by presenting the Tetragon project. We will of course explain the power of the tracing policy. Lastly, we will understand how we can extend our observability use. So when preparing this episode, I have started by looking at the documentation of Tetragon, and suddenly I felt pretty much stupid, or maybe I didn't have the right skills to get started in Tetragon. So to build this episode, as usual, I have built a tutorial, a GitHub repo, and this repo was the right excuse to start playing with Tetragon. My intention was to build my own tracing policies and technically configure them and see any type of use case that could be relevant for my use case or for my project and so on. So but before we jump into the technical assets, let's remind the real purpose of Tetragon. Tetragon is a project provided by the amazing Cilium community. If you never heard about Cilium, I would recommend to watch the episode dedicated to Cilium. The Cilium community is very involved in the eBPF community, so no surprise, Tetragon is the component designed for real-time security observability during the runtime of our Kubernetes workload, and Tetragon is able to detect so many things. I mean, process execution events, system calls, IO activities, including network or file access. I mean, there is so many things you could discover. It's just impressive. But more than just detecting events, we have the options within Tetragon to react by creating an enforcement actions to kill a potential suspicious events. By relying on eBPF, it will detect kernel events without adding any extra override to our application. So when working with Tetragon, I was mainly thinking about security use case, but once I understood the potentials of Tetragon, I started to use Tetragon to collect observability data, as usual, that I did not have by default in the observability solutions of the market, like the traditional Prometheus exporters provided by the Prometheus operator. So yes, we can clearly do advanced security enforcements, but we can also extend heavily our observability due to the flexibility of Tetragon. So let's have a look at the architecture of Tetragon. So when deploying Tetragon with Helm, you will have one deployment for the Tetragon operator. Why the operator? Well, you will see later, Tetragon introduced new CRDs helping us to configure and create new tracing policies. Then we have the Tetragon engine, which is a daemon set that will add the eBPF-Powered that will collect all the kernel events that we need. And we'll have two services that will mainly be used to expose Prometheus metrics. So one service for the Tetragon agent to see the health of those agents, and one for the operator metrics, so to see the operator health. Out of the enforcement feature provided by Tetragon, Tetragon has a different philosophy compared to Falco. Remember, Falco is a rule-based engine, so to make it pluggable, Falco provides default rules helping us to detect out-of-the-box common suspicious events. In the case of Tetragon, well, there is no default policy. From their documentation, I think the Tetragon community is planning to provide a set of tracing policy, so a bit similar to OPA Gatekeeper that provides predefined policy that we can choose to deploy. Anyway, as of now, you will have to create your own policies. But even if you have no tracing policies, Tetragon will report all the process exec and process exit. So you could look at the process running, ending in your cluster, Tetragon will create a log line with the event captured by Tetragon. This event by default will have lots and too much details. Here's an example of a process execution detected by Tetragon. As you can see, we have lots of various sections in this event. So the type of event, so here it's a event process XCV, or it could be a process exit. And within the event, you will have a process objects, parent objects, the node names, and the time of the event. The parent corresponds to the parent process, and the process, of course, for the current process. You'll find the similar details on the parent and the process. So the binary, the arguments used to launch the process, the pod details, the Docker details, the PID, UID, and so on. So depending on what you would like to achieve from these details, they are clearly, in my perspective, too many details that are not useful for all our use cases, specifically for observability. That is the reason you may need to configure Tetragon to export only specific events. So for example, process exit and exit, and the events related to our tracing policies. So KProbes, Uprobes, Tracepoints, but we'll touch base on that later on. You can also request to filter on events only on a limited number of namespaces. And last, we can define a filter on the fields that you would like to have in the export event. I will clearly recommend to configure it properly. To simplify how you will deal with the data produced by Tetragon, it makes sense to reduce the quantity of data produced by Tetragon. So the configuration of Tetragon can be done during the installation or simply modifying the config map used by the Tetragon agents. In the Tetragon namespace, you will find the Tetragon config map, helping us to adjust those settings. So here's an example of the config. As you can see in this example, I have filtered out few namespaces. So here you have the export denied lists. So with the namespace Cilium, Kubesystems, Threat Manager, Dynatrace, it could be more in fact, those namespaces won't produce any events. And also I have reduced the number of fields that I need to export with the settings field filters. So fields, and then you list the fields that you would like to have. So process dot binary. So remember, it's like a JSON object. So process.binary, process.arguments, and so on. So you can basically define what are the fields that you need. You can add the pod details of the process or the parent, and so on and so forth. Field filters provide also a syntax that could be used to filter field based on the type of events. For example, here I can say for all the process execution, those are the fields that I need. And for example, for the process exit, I will have a different structure, for example. So at the end, I will have various type of fields based on the event set. Another important aspect in the configuration of Tetragon is the various options that we can enable. So the first option is enable Kubernetes API that will add pod details to the Tetragon event. It means that Tetragon will interact with the Kubernetes API. Enables process cred, these credentials. This will report the process objects with the credential details of the process, so PID, UID, and so on. Enable process NS, so it will add the namespace details in the process objects. So not the notion of Kubernetes namespace, but the actual namespace details of a Linux process. The other amazing settings is the notion of throttling. So why do we want to throttle? Well, simply because Tetragon can easily generate too many events. So these settings will configure the number of events per period of time. So you will need to add an extra arguments in the boot up of your Tetragon daemon sets that will define the throttling. So for example, here you can see cgroup rates. We have 100,1 minute means 100 events within a minute. Once the throttling is in place, don't worry, Tetragon will generate a throttling events to let us know when it started to throttle and when it has ended to throttle. Throttling is great, but we're losing details at the moment of when the events is being throttled. So in the case of security runtime, it sounds crazy to suddenly become blind during a few seconds. I would rather having an options to control the number of similar events reported to avoid having the same events reported on and on and on, which at the end is going to just pollute the data that we're going to store in observability backend. Before we jump into the tracing policy, I think it makes sense that we remember the various type of events that Tetragon can produce. We mentioned a few minutes ago that by default, Tetragon will generate events on the process execution and the process exit to capture the execution of all your processes and the end of the processes. But Tetragon supports more type of events. So we have the KProbe, the Uprobe, Tracepoint, and LSM. Each of those events we produce by creating a specific tracing policy. We'll see in a few minutes the difference between each of those events depends on how you have created the hook points to your kernel. Tetragon offers various ways of detecting events. So for example, KProbe will basically listen for any kernel functions. It's in fact the most easiest way of configuring, but you need to select properly the kernel functions to make it sure it will be compatible in your environment, in all the nodes of your cluster. Remember, there are specific kernel functions for RNN64 architecture or x64 architecture, but usually in Kubernetes we should mainly be used on x64. Then we have Tracepoints, which is a bit more robust. It will be basically define the type of kernel events that we would like Tetragon to listen to. Then you have Uprobe, U meaning user, so user space. So it's a bit like a KProbe, but instead of a kernel functions, it will attach a eBPF-Probes on the user space functions. For example, let's say bean bash with the cat functions. Tetragon provides two new CRDs, the tracing policies that will be applied on the entire cluster, and then we have the tracing policy namespace to target a policy on a given namespace. So both CRD will have the similar properties, so let's cover the tracing policy, and at the end it will be the same for the namespace one. The most complicated part in building a policy is to configure the hook point. What type of events, kernel functions, user space, whatever should I attach my probe. So for example, here is a tracing policy, TCP send monitoring, where here we're focusing on a system called TCP send message. So in my case, I have configured mainly KProbes and Uprobes and Tracepoints. In this example, you can see that the first property is defining the type of hook points in KProbe, Tracepoints, Uprobes. In this example, it was a KProbe. At the end, we need to define first the kernel events or the kernel functions, and then we need to fine-tune the arguments that will help Tetragon to extract from these events the content, the context that we need to build our policy. So let's have a look on how we should proceed. Again, this is my recommendation. It may be not the best one, but at least it's a good starting point. The most important part of the journey is to understand how the kernel is supposed to behave on a given situation. For example, if I want to deal with receiving a TCP packet or writing a TCP packet, if I know exactly the system calls or the events, then it will be easier to define the right function. So by understanding this journey, it will help me to understand what are the events or kernel functions that will help me to build my tracing policy. So the first thing you should do is to search on how to attach the probe to the right functions or events. In my case, I want to be able to collect the number of bytes and the destination of each single container. So to do so, I have first look at the available kernel functions. So you can simply look at proc call sys, and by simply doing a cat on this, it will return all the kernel functions. So then you can identify the one that you make sense. In my case, I wanted the TCP send related functions. So I will do a grep to get only the TCP functions that has the TCP send name in the function. And once I have the desired functions, then I need to have the function definitions. These details is at least super crucial to configure the tracing policy and ask Tetragon to collect data from the output of these functions or the input of these functions. So you can have these details using perf probe, and then you ask the -vars on the name of your kernel functions, for example. If you don't have the perf utility in your system, it's not a big deal. Usually those kernel functions are documented online, so you can check at basically the definition of this given function. So this is for the kernel functions, but it will be the similar journey for a tracepoint. In the case of a tracepoint, I need to list the category of events. So we can do sudo ls syskernel debug tracing events. And here I will have all the different folders, and I can see that there's a category TCP. So then I will go further on going to the TCP events, and I will get the sub events for the TCP category and the available trace points. So in my case, I don't have any events that will match my use case. So for example, instead of using TCP send, I could try to look at the TCP retransmit to detect any retransmit situations that could happen in my environment. So let's see how we can use this. So first, we need to have the details. So by running this command, it will return the description of the event with the various fields and their type. So we could imagine then to configure our tracing policy with these details. So here again, tracing policy. So here I'm defining a trace point. I have the subsystem TCP and the event is TCP retransmit. And then you can see that I'm defining what are the arguments I'm interested in. So index 5, index 6 to get the socket details and so on. So we can capture the socket informations and the SKB information. For KProbes, Tracepoints, Uprobes, the argument is the critical details that will be very important to configure in the tracepoints. So you need to define what Tetragon is going to extract from the event and add it in the output. By the way, the details of the arguments extracted will be available in events in the args field. So in my example, here it is. So I'm asking to extract from the kernel the TCP send function, send message, and I will take the first parameter and the second one. Out of just defining the index, you need to define the right type to let Tetragon convert the data properly. So here is the actual available type available in Tetragon, so you have plenty of them. So the game will be to look at the definitions and try to match one of the available types that Tetragon supports. For me, identifying the type of the argument is the most difficult part, but with practice, I guess it should be much more easier. Then once we have defined this, we need to define the selector to precise when we want to raise this event. So for example, we can specify the specific binary or path of a file or IP address indicator of TCP communications. So the tracing policy has several types of selectors. So we have match args to filter on the value of an argument, match return args to filter on the return value, match PID, match binary, match namespace, match capabilities, and so on and so forth. In the case of our TCP example, I will limit the event to a specific IP range. So let's say I'm not interested in the local host communications. Here is the example, TCP receive monitoring, and you can see that in the bottom I am filtering the match args. So here I'm looking at the arguments that I've extracted, and I'm looking that the address is different from local. In the other type of filter, we are not relying on the details of the trace points or the KProbe, but on the default details provided by Tetragon, so much more easy to configure, like the binary, the capabilities, the Linux namespace, so very much easier to configure. And last, I guess you were waiting this for since the beginning, you can define an actions on the filtered events with the match actions. Match actions will allow us, for example, to kill a suspicious events, but we can do more. So here are the type of actions that we can do. So sigkill, signal, so we can send a specific signal to the process, override to send a specific value to the process, follow FD, unfollow, copy, get URL, DNS lookup, post. On the observability side, well, I would say Tetragon is insane. You can build trace points reporting things that you cannot imagine. The number of bytes written or read by a given container, binary, the TCP details, in fact, anything using a kernel event or kernel function. So technically, everything. So Tetragon could clearly extend the visibility on security events, but you can also use it to extend the visibility on your container usage. So I think it's not been designed for this initially. And again, if you're not applying the right selector, then Tetragon will produce tons of events, so tons of logs. So the level of details will come, of course, with a price. So let's focus on the observability data that Tetragon is exposing. So like mentioned before, Tetragon provides two services exposing Prometheus metrics. So the one related to the Tetragon agent, so the daemon sets with the eBPF-Probes, and the one from the operator. Due to the volume of events produced by Tetragon, sometimes we don't see the actual errors of our tracing policy configurations in the Tetragon logs. So with the metrics, it is clearly helping us to understand what has been rejected, the problems within our tracing policy. So the metrics will report the number of events in error, the tracing policies that has not been properly loaded, and more. So if you simply look at the metrics produced, there are lots of dedicated metrics to the events and the tracing policies. For example, the size of the data events, the tracing policy loaded, and then we have specific metrics on the behavior of the Tetragon agents. There are lots of details on various cache, for example, the number of events in cache, the number of BPF events failed, and also it has this notion of queue and capacity. So I've built a few ratios to keep track on this. So the first to keep track on the BPF map capacity by building the ratio, so the number of event versus the capacity. The process cache, so two metrics are available, so the size and the capacity, so we can also build the ratio to plot the capacity of this cache. So the great news is that Tetragon has documented all the metrics. So here is the link to the metrics exposed by Tetragon. The only thing that could be very helpful from the community perspective is to give more explanations on the technical metrics like the cache that are important to detect abnormal behavior on the Tetragon agents. But the other smart thing built by the community is the ability to control the cardinality of the metrics, because similar to the log produced, by default Tetragon will add lots of dimensions to our metrics. So we can control that by configuring either Tetragon we're using the config map or simply using Helms. That's it for today's episode related to Tetragon. So Tetragon, if you just look at it like this, it's an insane product. There is so many things we can do. The only thing which is really complicated is the configuration. So I would really love to have examples of tracing policies, more of them. There are a few of them available in the repo of Tetragon. It would be great that those tracing policies are covering the most known use case that we may know in the market. But again, if you start to understand the kernel events that you're looking for, the events from the Tracepoints perspective you can look at, and then configuring them properly, then you will see the details are insane. So I've done a couple of examples. For example, I'm using Tetragon to help me identify the right kernel capabilities for a given workload, and I was not able to do that with other tools. So I think it's super powerful. And also in terms of resources, it consumes, again, a reasonable number of resources for the quantity of data it's able to detect. So very surprised by all what you can achieve with this solution. And as usual, again, like I mentioned at the beginning of this episode, I have built a GitHub repo with the tutorial that I'm using for this episode. So check it out, it's out here. If you want to play with it, look at the tracing policies that I've defined. It's at least a good start, but again, I'm far from being an expert on Tetragon. There are plenty of other people that have built amazing tracing policies, so you should probably look at what they've achieved. So if you enjoyed today's content, don't forget to like and subscribe to the channel. So see you soon for another episode. Bye.